Okay, we're going to be doing our 77th problem today. This is going to be the 77th palindrome partition. So in this particular problem, what we're given is a string, and we need to separate out every substring. So take the first item, and take the second item, and take the third item. Those are all, if all of these substrings are palindromes, or AA and then is a substring and then B is a substring, and they are palindromes in itself, then it is a valid, and we want to store that. However, if, like, say, suppose you have AAB, that's not palindrome, then we don't store that. So how we're gonna do this when it's a decision tree again. So how we're gonna partition it is that we're gonna partition it by one item, two items, and all three items. Then with that, we take two items. So we have so then we take one item each as we go build on. So we take an A, or we take an AB, right? As you can see here, the AA worked out for us, and the AB did not. So we keep on continuing with AB, and once we hit the end of the length of this particular string, then we can append this particular part to our results, and we have one partition. So that's like a subset, and then we take two items, like two A's, and the only other possibility is to go get the B, and we got the B, and that is another partition, and AAB is not, and we do all three, and that's the end of the problem. So this particular problem falls more in line with this particular way of doing a, what do you call this thing, a backtracking. So we get results, we get an empty item, and we can now run DFS on the I, because we're moving I forward, trying to finish the I up into the length of the string. And once we get to the end, we're gonna append the part and store it. The fastest way to do this is to get the part inside the DFS again. So we take a part, and if it reaches I is at the end of the string, let's store that part, and let's keep passing it on. So right. So let's do for j in range of I through the length of s. So basically, this captures our first item here, whether we choose one item, two items, or three items. So we're gonna say if is palindrome of s string I through j. So basically, for first item, we take only the first item, and then we take the second item, and take the third item. This does the same thing. Basically, we're going to repeat this process if this current part is a palindrome, and we're going to do it for all the substrings. So basically, if this is let's say a z, we're basically going to do AAB for z itself, and we're going to do all of this as well. So basically, it's passing, it's recursively doing the same process over and over again in DFS, which is to get every single substring at every single different length for this particular partition. So dot append s I through j plus 1 to account for the ending point plus 1. And that's where we're gonna start. We're gonna start at where this particular place ends, depending on wherever we end. If it ends at the when it ends, then that's where it ends. So and then that's where we begin our process again. So this is a process where we repeat the process within the process. Yeah. So then we return the results. Of course, then we need the part, which is empty array, and I think that's good to go. Let's run the code. Whoops, not the trash button. Okay. Oh, right, we forgot to create the function palindrome. Let's see if we can do it down here. I'm not sure if we can, or do we need to create it up there? this is a good time to try. So while I is less than j, if s of I does not equal s of j, then return false. Else, you know, I and j equals I plus 1 and j minus 1. Then return true if this passes. One thing I do wonder, let's run this code first, is that if we could just reverse the string here, the part. Oh, throw in the part. Reverse the string by just, reversing it and seeing if that works. Let's submit first and let's start experimenting a little bit more. So, oh, it's a lot slower. Weird. Let's put part out here then. And let's see what's going on now. So lose the parts, run it, submit. I don't know. These things are weird. Okay, it's slow. All right, I don't know what's going on. So anyways, let's try this s of I through j plus 1. Let's go -1 and equals s of I j plus 1 to by 1. So if return that, see if that's possible. That's what I don't know if that's possible. I don't think it's possible. Yeah, it's not possible. Yeah. Makes sense. All right, I think this is the way we're doing it is good enough, and we're solving the problem. And we tried something new. It didn't work out. That's fine. But what we learned today, is that if we want to for some patterns, we do need to learn this new method of doing backtracking instead of just creating using a pop method. Instead, we should use this for method for as we grow the string, the substring, and move on from different parts of the substring. It was a good lesson, and I hope to do more, and we can use this pattern in more places so we can get better pattern recognition when we see these types of problems. And that's all I have for commentary today. Thank you very much for watching. If you enjoyed the video, like and subscribe, and I will see you in the next one.